my name is Redo Meyer and I'm the tech lead for Google's Android Developer Relations team. In this efficient data transfers DevByte, I'm going to demonstrate a couple of quick techniques that you can use to better understand when your application is making network requests. The aim is to modify the data transfer profile of your apps to optimize for minimizing the battery drain caused by activating the cell radio. As you may have already seen in my DevByte on understanding the cell radio, it's good practice to use the big cookie approach to data transfers to avoid a fragmented network traffic profile that keeps the cell radio powered up indefinitely, in favor of minimizing the number of radio state transitions. Now, before you optimize your code, you need a way to generate these graphs that show exactly when your app is transferring data, and to understand what you're looking for, so you can look for areas that need improvement. There are several tools you can use for this. Most simply, you can use Logcat to generate log entries that define the timing information of your network requests and at their start and endpoints, and then use the exported log file to graph the output using the graphing tool of your choice. If you'd like someone to handle that graphing step for you, AT&T offer the open source application resource optimizer, or Arrow tool, that will generate the pretty graphs and even overlay the battery state model, as well as providing you with specific recommendations based on their analysis of your app. Another great alternative is to use the Network Statistics tab in the DDMS view, which is part of the Android developer tools. As you can see in this screenshot, it displays the amount of data being transferred and the direction of the data flow. Additionally, you can tag your output sockets to color code your data transfers, making it easier for you to see where each transfer is originating. If you're using the HTTP client to execute your transfers, the thread stats tag associated with the current thread will automatically be associated with the socket used for transfers using the HTTP client. Note that for socket tagging to work, you need a device running Jelly Bean or higher. So once you've generated a representation of your app's transfer profile, you can start analyzing it for battery inefficiencies. The most important thing to look for are any periodic transfers. Any regular pattern of repeating transfers will cause a correspondingly regular pattern of radio activations. So you're effectively setting the minimum level of battery drain. So the shorter the period between updates, the higher the battery drain. Now in this example, the period is 15 seconds, more than enough to keep the battery powered up indefinitely. But depending on the device and carrier, even a period over a minute may be enough to prevent the radio from ever dropping into standby mode completely. Now we can incrementally reduce the battery impact by lowering the frequency of these regular transfers, but a better approach is to try and eliminate periodic updates completely, allowing your app to have a baseline of no battery drain. Now, periodic data transfer spikes are typically an indicator of either a regular scheduled upload, such as analytics or ad impressions, or client-side scheduled polling, generally implemented using a timer or a repeating alarm. You can eliminate both using some simple best practices. Anything that's not time-sensitive, such as analytics data, ad impressions, or anything else that doesn't have a direct impact on the user experience, should be queued up and batched to be transferred together as a group. The best approach is to simply fill the queue and trigger all these delay-tolerant downloads the next time you need to perform something that is time-sensitive, like downloading new music, updated headlines, current sports scores, whatever data your users are interacting with. If time-insensitive data is the only data you transfer, you may find it necessary to schedule a daily sync. In that scenario, the best approach is to use a sync adapter to handle this for you, and we'll cover that in another DevByte. But where a repeating alarm is the only thing that will work, you can try and optimize that by randomizing the periodicity as shown here, and make the frequency as low as possible. If you're polling your server to check for updates, you should do everything in your power to replace client-side polling with Google Cloud Messaging. This technology lets you send messages from your server to specific application instances through Google's cloud messaging infrastructure. So instead of having each device poll your server every 1, 5, 15 or 60 minutes to check for updates which may or may not exist, you can have your server notify each device when there's new information ready for it to download. The result is an improved user experience thanks to both better battery efficiency and lower latency updates. I examined both sync adapters and Google Cloud Messaging in more detail, as well as exploring some other approaches to eliminating repeating transfers later in this DevByte series. For now, having eliminated periodic transfers, let's look at some more indicators for potential efficiency improvements. Another pattern to look for is short spikes, either in height or duration. While they may not be regular, they typically indicate transfers that could be bundled together in the same way as periodic transfers, or possibly batched together or even prefetched. The same thing goes for transfers of any kind that happen in close proximity but don't quite overlap. Now, it's significantly more efficient to have transfers happen when the radio is already in its active state. So when a time-sensitive transfer is initiated, for whatever reason, you should look to preempt any transfers which are likely to occur within the next few minutes. This is particularly true of any scheduled transfers, but also includes potentially user-initiated transfers. Now, for example, say you have a news app. If you're forced to perform a download to let the user read a full article that you haven't yet prefetched, you should use this as an opportunity to prefetch other articles that they're likely to read next, particularly if switching between your articles is as simple as swiping left or right. Now, alternatively, if the action is time sensitive but not critical, for example, uploading an image, it might be worth holding off for up to 30 seconds just in case another transfer is initiated in the interim. Now, perhaps not surprisingly, this functionality is built into the sync adapter, which also handles things like lost connectivity and batching transfers across applications, so it makes it a great approach for handling all of your data transfers. I'll dive into that and further efficient data transfer topics in more detail in other DevBytes in this series, including how to implement some of those best practices using simple code patterns, Google Cloud Messaging, and the sync adapter.